Hello, this is the metric system. So what is the metric system? It is a system used to measure units. It is commonly used by most of the world, however in the United States we use the imperial system, along with a few other countries. The different units are kilo, hecto, deca, unit or base unit, deci, centi, milli, micro, nano, and pico. So starting from our base unit and going left, the units are going to be getting bigger. But starting from our base unit and going right, our units are going to be getting smaller. So since we know that each unit is a multiple of 10, we know that 1 liter, which would be our base unit, is the same as 1,000 milliliters. Or 1 kilogram is the same as 10,000 decigrams.
Why do we use the metric system? The metric system allows for scientists across the world to use and understand the same units of measurement. If one person used cups and another person used grams, it would be inefficient to constantly convert from one system to another. This also makes measurements less and less accurate as more conversions are made. The metric system in particular makes it easy to convert from one unit to another since it is built on powers of 10. It is easier to simply move a decimal point to the left or right rather than having to divide or multiply by irrational numbers or fractions like 1/2.
So here are some common units of measurement that we use with the metric system. So for length, we often use meters, which we can see as centimeters on a ruler, or kilometers for more long distance. For mass, we often use grams, which we typically see with kilograms or milligrams. For volume, we usually use liter, which is often seen for liquids. And some other recognizable units would be milliseconds for time, kilojoules for energy, and moles for amount of matter, which is often used in chemistry.
What are the units? The units are kilo, which is 1,000, hecta, which is 100, deca, which is 10, unit, which is 1, deci, which is 0.1, centi, which is 0.01, milli, which is 0.001, micro, which is 0.0001, nano, which is 0.00001, pico, which is 0.000001. It is important to memorize these units in order. So a simple way to memorize these units in order is by the sentence, King Hector died unexpectedly drinking chocolate milk Monday night painfully. You still might be confused, so let's practice some examples. Moving decimals. When moving decimals, remember the sentence King Hector died unexpectedly drinking chocolate milk Monday night painfully. The first problem is convert 300 nanometers to decimeters. Nanometer starts with an N, which is night right here, and decimeter starts with a D, which is drinking right here. So we have to move the decimals 1, 2, 3, 4 times to the left, which would be 0.03 decimeters. The second problem is convert 57 decaliters to milliliters. So decaliter starts with a D, which is died, and milliliter starts with an M, which is milk right here. So we have to move the decimal 1, 2, 3, 4 times to the right this time, which would be 5,700,000 milliliters.
So let's do some practice dimensional analysis problems. We're starting off with how many centimeters are in 12 meters. So we're starting with meters and we're trying to get to centimeters. First, we're starting with our beginning number and unit, which is 12 meters, and we will set this up with the standard dimensional analysis grid, which looks like this. So we always want to cancel out our units, so meters are going to be going on the bottom here. For every 1 meter, there are 10 decimeters. Again, we want to cancel out decimeters, so decimeters are going to go on the bottom. For every 1 decimeter, there are 10 centimeters. Since all of the 10s are on the top, we're going to multiply 12 by 10 by 10, or since we know 10 times 10 is 100, we can multiply 12 by 100, which gets us to 1,200 centimeters. Here we have kilograms and 30 grams. We're going to start with 35 grams and we're trying to get to kilograms. As usual, we want our grams to cancel out. However, this time, since we know the decimal is going to be moving left and the number is going to be getting smaller, the 10 is going on the bottom. So for 10 grams, there's 1 decagram. And then for 10 decagrams, there's 1 hectogram. Now for 10 hectograms, there's 1 kilogram. And since the 10s are on the bottom this time, we're going to be dividing. So that would be 35 divided by 10 divided by 10 divided by 10. Or, since we know 10 times 10 times 10 is 1,000, that would be 35 divided by 1,000, which gets us to 0.035 kilograms.
Our first problem is on dimensional analysis. We are asked to find the amount of seconds equivalent to 1,200 milliseconds. First, we start with our given amount of 1,200 milliseconds. Then, we cancel out our units by converting milliseconds to our next unit on the way to seconds, centiseconds. You can reference the acronym of King Henry died unexpectedly drinking chocolate milk Monday night painfully if you ever need to remember the order of the metric system. Also, don't forget to keep track of the powers of 10 for each conversion. Here, 10 milliseconds is equal to 1 centisecond. Notice how the units cancel out from across from each other. If you ever get confused on where to start with the setup for dimensional analysis, you may want to start with the units first. As long as your units cancel out and you're not skipping any conversions in the middle, you should have the right setup. Sometimes there are a lot of mixed-up conversions, like in this problem, so be sure to leave a lot of room for dimensional analysis problems. Now, we convert 10 centiseconds to 1 decisecond. Lastly, we convert 10 deciseconds to 1 second. We have reached the units we want, so we can stop converting here and begin calculating our numbers. After multiplying the numbers on the bottom, 10 times 10 times 10, we have 1,000 as our denominator. Next, multiplying all the numbers on the top, we have 1,200 as our numerator. Dividing 1,200 by 1,000, we end up with 1.2 seconds total. Now, the second problem is about moving decimals. We are asked how many liters are in 5 kiloliters. Once again, we start with the given amount of 5 kiloliters. This time, we are starting from the bigger end of the metric system. We move from kiloliters to hectoliters, hectoliters to deciliters, and deciliters to liters. So, since we moved 3 times to get to liters, we move the decimal point 3 times to the right. Remember, since we are moving from bigger units to smaller units, we are moving our decimal point to the right because our number is becoming bigger. Our answer ends up as 5,000 liters. Here are some extra videos for more example problems and help on the metric system if you want to deepen your understanding of this topic. Thank you for watching.